Hey party people, Techno here, and we are back again at the Sans Holiday Hack Challenge 2022. In the last Hack Challenge video, we wrapped up this Jolly CI/CD problem, and we retrieved the Elven Ring. So the Elven Ring is now in our possession, so let's begin our quest to retrieve the next ring of powder, which is the Web Ring. And so we are going to head back out of this elf house, back through this flooded cavern, and back into the tunnels where we can mosey on over to the Web Ring room. Now what we're going to be dealing with when we get into the Web Ring room is an archive called Boria Artifacts. And Boria Artifacts contains two items for us. It contains a PCAP file and it contains a web error log. You can use both of these to solve the initial set of challenges that we're going to encounter in the Web Ring room. I only found it necessary to use the PCAP, so that's what I'm going to focus on. I didn't really find it necessary to jump into the web error log, but it is there if you want to use it. So once we get in here, we're going to have a conversation with Alabaster Snowball. Alabaster is going to turn over that Boria Artifacts archive for our analysis. And let's go ahead and take a look at our badge and what the first set of challenges are. So in this video, I'm actually going to tackle a few challenges because they all deal with this PCAP. And right here we go, recover the web ring. You may notice that I did not actually finish out the web ring challenge and recover the web ring. I got right up to the last challenge, at which point I ran out of time and was unable to solve that challenge before the Holiday Hack Challenge was officially over. So I'm not going to present a solution to something that I wasn't able to solve before there were, a bevy of other walkthroughs and how-tos out there. Don't want to take credit for something I didn't do. So I will walk you as far through this one as I was able to get in the last challenge. Yeah, I might go around or might approach solving it here again soon, but not in a recorded way. So our first set of challenges are the Naughty IP, Credential Mining, 404 for the win, and IMDS, HHC, and other abbreviations. Those are the ones that we're going to tackle in this video. Starting with Naughty IP, 1 Christmas tree out of 5, so pretty simple challenge here. And what this says is it states, use the artifacts, and then we have a link to that Boria Artifacts archive, from Alabaster Snowball to analyze this attack on the Boria mines. Most of the traffic to this site is nice, but one IP address is being naughty. Which is it? Visit Sparkle Redberry and the Tolkien Ring for hints. Well, if we have hints, let's check out our hints and scroll on down to where we will find this hint for the first challenge called Wireshark Top Talkers. So the victim web server is 10.12.42.16. Which host is the next top talker? And then we have a link to top talkers in Wireshark and how to get those. But what we're going to do here, let's just go ahead and jump into the PCAP file and take a look. So the PCAP file in question is titled victim.pcap, and we have a whole bunch of traffic here, which most of it is not malicious. But if we want to establish our top talkers, then we can go to Statistics, Conversations, select our IPv4 addresses, because that's what we're dealing with here. And then at this point, all you really have to do is perform a filter on the packets column or the bytes column, whichever you prefer. Both are going to get you there. So you can see by no small margin, the greatest number of packets and the greatest number of data belong to this 18.222.86.32 IP. That's the top talker. That could be our candidate for this malicious IP. Now, the initial time that I went through this challenge, I think I just jumped right into it. I don't think I took a look at the hints. And I happened upon this IP in a slightly different fashion. So I'll show you what that was. And what I did to get a better feel for what we're dealing with in this PCAP file is I went to that same statistics dropdown, but I selected protocol hierarchy. And in protocol hierarchy, it's going to break down the kind of traffic that we have and, the percentage of the packet capture that it makes up effectively. And what I noticed here is a rather small subset of packets, in the case of XML, very small, but a small subset of packets dealt with URL encoded form data as well as XML. And I thought, hey, that looks interesting. That kind of stood out to me. So I selected that and hit apply as filter. And when I did that, I got to this same 18.222.86.32 IP address and sending traffic to our victim machine. And the kind of traffic that it was sending to our victim were post requests to this /login, and a ton of post requests. You can see that there are just an absolute ton of these. So to me, that looks pretty malicious. That looks like a brute force login attempt. So I said to myself, hey, self, 18.222.86.32 looks pretty malicious. Let's give that a try. Turns out that is the answer to this challenge. And if you go to your badge, having not solved these, then there will be a section where you can type in the answers to each one of these questions and just hit enter and submit that. So naughty IP, we established what that is. The next one on our list is credential mining. So again, 1 Christmas tree out of 5, not very difficult. But this states that the first attack is a brute force login. Yeah, no kidding. We just saw that. What's the first username that was tried? So this link will take you to a description about brute force logins and give you more background information there. But what we can do to address this challenge is just jump right back into our capture here and set up a filter that's going to pull out only the packets in question that we're interested in. And to do that, we can start with an IP source equals, and then our malicious IP. As we know, all of this traffic, all this brute force login traffic is going to come from 18.222.86.32. And then we're also dealing with HTTP traffic, but even more specifically than that, it's all going to be post requests being sent to that /login URI. So we could construct a number of different filters that are going to get us here. We could say every request method that's a post, we could throw that in there. The one that I chose to go with was http.request URI contains login. And this should filter out all of the packets of interest for addressing this challenge. So if we go back to the top and look at the first packets that come in, we have a couple GET requests to this login URL, but where we're going to be concerned is with the first post request, because that's where that username and password is going to be sent to the victim machine. And selecting this packet and scrolling down to the form data, we can see that the first username tried was Alice. So there's the answer to our next question, Alice. Let's go back to the badge and look at the next challenge here. Next one being 404 for the win. Again, 1 Christmas tree out of 5, not super difficult. And it states that the next attack is a forced browsing. So forced browsing is effectively where we just try a ton of different URLs to see if we can access a resource at that URL and basically determine whether it exists or not. So in this case, the next attack is forced browsing, where the naughty one is guessing URLs. What's the first successful URL path in this attack? And then, of course, a link to more context and background on forced browsing. Here again, we can construct a filter in Wireshark that is going to help pull out only the packets of interest and show us where those URLs exist. And the title to this objective is a bit of a clue as well, where it states that 404 for the win. So in this case, let's do another IP source and grab all of the traffic from the malicious IP address. So .86.32. And let's filter that a little bit more. What we're looking for here is going to be requests trying to fetch a URL. So that's going to be a GET request. So we can further filter this by saying http.request method and define that as being equal to GET. And now we're going to want to see the responses here as well, because we're going to see GETs to a ton of different URLs. If I just filter on this right now, you're going to see where we're making those GET requests to all of those different URLs to try and figure out whether they exist or not. But this is not going to be enough information for us to determine whether any one of those were successful, because we need to see the response that comes back. If the URL doesn't exist, most likely we're going to get a 404 error. So in the title of that objective, 404 for the win, we're going to get a 404 error coming back in the response if that's not a valid URL. So what we can add to our filter here is we can add an OR. So in Wireshark syntax, adding an AND parameter is going to be 2 ampersands. Adding an OR parameter is going to be 2 pipes. So now let's do an IP destination because we only want to see responses that are going back to our malicious IP. .86.32. And we can refine this by saying that the http.response code, we could do this 2 ways actually. We could say show me every response code that is not, so we can negate this with an exclamation point at the beginning of this parameter, and we could say not equal to 404, so that'll show us everything that's not a 404. Alternatively, what you could put in here is say show me every http.response code that's going to be equal to 200, because if that URL does exist, our GET request is going to return a 200 OK. Now when we filter on this, sure, we're going to get those initial GET requests to that login page where we saw the brute force attack, and then we're going to see a whole bunch of these 200 OK responses that were part of that brute forcing of the login. Those were posts though, so they're not showing up in our filter here. What we need to do is just scroll down until we find our first GET request, and then take a look at what follows. So now you can see we've switched over, and now we have all of these GET requests. Get/index, get/images, get/download, just all kinds of URLs that we're trying out. But we don't have any responses to these because our filter is removing anything that's not a 200 OK. And if it's not a 200 OK, in this case, it's most likely a 404. So these are not valid URLs. So now that we're in our gets, we really just need to continue scrolling until we find that first 200 OK response. And that's going to signify the first URL that was successfully found in this forced browsing attack. So we'll continue to scroll. And man, there's a lot of traffic here, which makes sense going back to those initial conversation statistics. This IP had the most data and the most packets associated with it, and now we can see why. So here we have the first 200 OK response, and it is in response to this get/proc. So the first URL that was successfully discovered is /proc, and there's the answer to the next question, or to the question we're working on now. Moving on to the very final question dealing with these Boria artifacts, and that is this IMDS, HHC, and other abbreviations. Stepping up the difficulty just a tad at 2 Christmas trees out of 5. This one reads, the last step in this attack was to use HHC, or XML external entities, to get secret keys from the IMDS service. What URL did the attacker force the server to fetch? So HHC is where we use, basically, we make a request via XML that is not going to be handled properly, and it's going to result in being able to fetch resources or execute commands on the target system that really you shouldn't be able to do. That's the vulnerability. So let's jump back into the PCAP, and here again, we can construct another filter that's going to narrow us down to only the packets, really, or mostly only the packets concerning this attack, and we can take a look at what's going on. So in this case, if we are sending form data, again, this is going to take us back to those post requests. So the first thing that we can change here is we can change the request method to post, and then we can add one more parameter here. This /proc is going to be the vulnerable URL, and that is where those post requests are going to be sent. So we can say http.request URI, just like we did for the logins, contains proc. And we want to keep the responses in here as part of this filter because that's going to help us give some context to where those requests are going and what is being returned. So let's go ahead and filter on that. And now at this point, we need to get past all of that initial post from the password brute forcing. So let's just keep scrolling. We're going to miss all of those gets that we saw as part of the forced browsing. And we get to this first post here to /proc. And that is going to be an XML request where we are attempting to perform an XXE attack. And the response to this provides back the data that was being looked for. So that validates that the attack is possible. The next thing that we'll see is the attacker tries to fetch the etc password file from the system. And in the response, we can see that they were able to do so. So executing those XXE attacks, gaining access to system files and resources that should otherwise be off limits. So now we see a post to, again, the system, this URL, and we're going to see the response to that. And we come back with this response here, product ID. Okay, so this is going to be where the attacker starts to construct the URL that we're looking for. That's going to lead to those keys, to extracting those keys from the IMDS service. So here, this is the first part of that URL, and you can see that the attacker will try to build this out over time. And for each response that comes back, another piece of the puzzle is uncovered. So in this case, we have product ID returns EC2, and in the next post, we see that that EC2 gets appended to the end of this URL. And that's going to keep going back and forth a few times, building out that URL until the final request here to this URL results in the secret access key and token and everything else of this IMDS service. So backing that up one more to the post request, this is the URL in question that we need to copy. That's our answer to this final portion of the challenge. So now that we have discovered what this attack is all about, what's going on here, we can go ahead and speak to Alabaster to determine what the next objective is. And that next objective is it will be to open the Boria mine door, which is going to be about a medium difficulty challenge, a 3 out of 5. So that's the one that we're going to tackle in the next video. And until then, thanks for watching, everyone. Really appreciate it. Take care, and I will talk to you later.